Okay, so I just uploaded today on Canvas some sample exam questions to help you prepare for the final exam. You can see there are three types of questions: multiple choices, description questions, and problem solving. So, and then there will also be a bonus problem included in the final exam. So take a look and let me know if you have any additional questions. And I also extended the requirement for cheat sheet. So instead of 2 pages, you'll be allowed 4 pages. And that's it. So let's move on. And today we're going to talk about, first talk about transportation planning. So in this part, we're going to have a high-level overview of the different transportation modes in supply chain and logistics, and talk a little bit about the role of government and policies in transportation, and then identify some of the comparisons between different transportation network design options, and understand what are the factors that compels us to choose one design over the other, and finally evaluate some of the trade-offs involved in the transportation network design. So, oops. Okay, so transportation is basically the movement of products or people from one location to another. So in the supply chain, we have transportation all the way from the beginning of the supply chain to serving the end customer and to the return process, the remanufacturing process. And transportation is a very important supply chain function because the production and consumption of products are rarely in the same location. So then we need to transport products from the place that they're produced and to the place where they're consumed. And then in the total supply chain costs, transportation accounts for a very large portion of it. In transportation sector is also a very large component of the of various industries. So, and it's valued over $10 trillion just in the U.S. itself. So when we talk about transportation options, you often come across the shipper, the concept of a shipper versus a carrier. So the shipper is actually the owners of the products. Right? So they are the company that requires products to be moved from one place to another. And sometimes the shipper and carrier are the same entity, and sometimes they're not. And carriers are the ones that actually conducted the transportation process, right? So, if we shop online and we buy some products from, say, Macy's, then this product, the shipper is Macy's, and carrier could be USPS, FedEx. So we need to make the distinction there. In terms of transportation modes, there are air transportation modes, truck, rail, water, pipeline intermodal. We also make a distinction for package carriers as a distinctive mode because of the characteristics of the products being transported by package carriers are different from the other ones. So in this table, you can see a rough estimation of the value transported by each transportation mode in year 2011 and the value added to GDP by different modes. So we can see a truck is the predominant transportation mode, and then followed by intermodal. And air accounts for only a fraction of the total freight value transported, but it does contribute significant to GDP. And also, in terms of transportation mode trend, if you compare this table with a table from 10 years ago, you would see multimodal transportation mode has significantly increased, about doubled compared to 10 years ago. So we'll quickly look through each of the components, transportation modes one by one, so we can evaluate their pros and cons and their suitability to different scenarios. So in terms of the air mode, so air is obviously a very costly transportation mode. Its cost components include, one is the fixed component, so which is the cost, for example, to acquire an airplane. Right, so this component is independent on how many flights are flown, and also independent on how many staff is on each flight, and the time involved in each flight. And the second component would be the labor and fuel related to each flight. So this number is fixed for each flight, but of course, as the number of flights increase, the costs related to labor and fuel would increase. And finally, we have the variable cost depending on passenger and cargo. So this would be the component of cost that would increase as more passengers are traveling on the same plane, or as we're carrying more and more cargo on the plane. So when we're planning a transportation network when using air mode, what are some key issues? One is basically, where are the airports, right? Where are the airports that are considered as hubs, and how many of them, what is the density, and so on. Secondly, fleet assignment. So how do we assign the current number of planes we have to different flights from various locations to various locations? And then we have maintenance schedules. So this is how do we schedule maintenance and crew labor to maintain the fleets we own. And also, similarly, there's also scheduling issues related to scheduling crews to serve on each flight. And finally, revenue management is a very big part of managing air travel. So where you can see prices will differ from time to time, and the availability under each price category would also differ from time to time and from flight to flight. So the second mode, transportation mode, is package carriers. So this is a distinctive mode because it can actually be carried by truck or by plane or by cars. So what makes it package carrier mode is just the definition of the packages being delivered by this mode. So generally, if we have packages that are less than 150 pounds, then we consider this mode to be package carrier. So this is the most expensive mode compared to others, and cost-wise, it cannot compete with other modes, but they do offer a lot of benefits. For example, their delivery is very fast and also very reliable. And the shippers use package carriers, therefore, for small and time-sensitive shipments. And in addition to rapid and reliable delivery, they also provide some other value-added services. For example, the benefit of being able to track your packages, right? And with the growth of online sales, the use of package carriers has increased significantly over the past few years. And usually package carriers will seek out smaller and more time-sensitive shipments than air cargo carriers, especially when the tracking and other value-added services are important to the shipper. And because of how expensive package carrier mode is, it's important to utilize consolidation in planning the transportation network for package carriers. So a lot of times we'll see consolidation in intermediate modes. So for example, we would see trucks that make local deliveries and pick up packages, and then they would drop these packages into a local consolidation center, which will then be probably consolidated into larger truckloads to another hub, and then this hub will then be dispatching vehicles, shuttles, trucks to deliver packages using milk runs, for example, in local neighborhoods. And we'll explain what milk runs are. Truck is the most commonly used transportation modes in terms of product delivery. So in trucking mode, we have two types of trucking transportation. One is truckload transportation. The other is less than truckload transportation. So as you can see, infer from the title, basically in truckload, we carry more in each truck, and in less than truckload, we carry less, right? So the utilization-wise, obviously, truckload transportation is higher. And so technically, truckload shipping is defined as a truck with a load of 10,000 pounds or more. And so the benefit of truckload delivery is cost efficiency for each truckload is very high. The challenge for truckload transportation is that usually from different in between different regions, we'll see imbalance of transportation flows. Some nodes are more of a sink than others. So for example, large cities like New York City would be more of a sink where we see more inbound flows and less outbound flows. So then without proper planning, we'll see truckloads going with full truckloads but then return with an empty truck. And obviously that is a loss of cost efficiency. So the challenge of a truckload delivery is how to schedule truck deliveries such that these empty truck returns are minimized. So for less than truckload shipping, we see more smaller lots being transported in each truck. And so this is the mode sort of in between truckload delivery and package carrier deliveries. So the less than truckload operator tends to run a regional or a hub and spoke system. So hub and spoke meaning you have a hub in the middle, and then you go to smaller spokes. And less than truckload delivery often needs to have some consolidation between different loads in order to make more utilization of the truck capacity. So as a result, it may take longer than truckload delivery because each load might need to wait for other loads to be picked up or to be dropped off. Another issue with truck mode is the fatigue-related accidents. In addressing that, the government has implemented some policies regarding to how long each truck driver can be driving each day to prevent fatigue in driving. And corresponding to that, now we have this new technology of autonomous truck and autonomous vehicles. So with that technology, perhaps the fatigue-related accidents would be significantly reduced. Then we have rail. So rail is a very cost-efficient mode to move commodities over large distances. And it does incur a very high cost in terms of building the tracks, building locomotives, building cars, and another significant cost of rail scheduling is the trip-related labor and fuel cost, which is independent of number of cars, but vary with the distance traveled and the time of each trip. So in rail transportation planning, the big issue is how do we schedule the railways to maximize utilization. because the per trip cost is incurred no matter the train is moving or stopped. So we want to, schedule the network of trains such that the stopping is minimized, and therefore utilization is maximized. Another consideration for rail is that even though it's called scheduling for trains, it's actually trains are more built than scheduled, because traditionally, in order to take advantage of economy of scale, right, a train cannot depart unless a certain number of cars are accumulated. So then a lot of times trains would sit in before departure for a long time before a sufficient number of cars are built. And a push is to reduce some of these built scenarios and then include more scheduling and release the constraints of having to build a certain number of cars. Then we have water. So since water, so it requires water, therefore we can only have water transportation when there is water. So we're limited to geographic areas, including ocean, inland waterways, and coastal waters. The good part of water, so ships, right, is that the cost is extremely low, and you can also transport very large shipments on the ship. The downside is it's very slow. It doesn't have complete access to a lot of geographic areas. But in international trade, this is one of the most used mode because of the cost efficiency, because the large quantity can be transported over a long distance. And in the past decades, we see an increase of use of containers for ships, which also leads to a growth in intermodal transportation, because containers can be easily transported between ships and between trains and trucks. Third one is, a particular one is pipeline. So this is, so pipeline transportation only applies to certain types of products, right? Petroleum, natural gas, and this one has very, very high fixed cost to build the pipeline infrastructure. As a result, pipeline is often only used for not only large flow, but also stable flow. So large flow is needed to justify for the high fixed cost, and the stable flow is to make sure that whatever capacity is built is highly utilized. And in pricing for this pipeline type of transportation mode, it usually consists of two components. Right, so one is a fixed component, that is based on the peak demand. And then another price component that is variable based on the actual amounts transported. So this pricing structure would incentivizes the shippers to segregate the stable part of their flow, use that for pipeline, and then use the uncertain part of their demand with using other modes. Finally, we have intermodal transportation, which is whenever we use more than one of the previous transportation modes to complete a shipment. And with the growth of containers, we see an increase in intermodal transportation, especially in global trade. And other than that, intermodal transportation is also a requirement because the majority of global trade is done through ship, which is only bring the shipments to ports along the coast, which is not really accessible to most markets. So then we need to combine it with other transportation modes, transport it on rail, on trucks, to bring it to other markets. And intermodal transportation, the only difference that makes a transportation mode intermodal rather than just a simple addition of different transportation mode is that it is managed by a single entity, right? So another benefit of that is for a shipper that's really convenient, rather than talking to ship and train and trucks and air, now we need to only talk to one entity, and that really simplifies coordination and information exchange. So in order to then, as the carrier of intermodal transportation, because the shipper has to deal with less of the coordination, this burden has been translated to the carrier. So within the carrier, we need to do more information exchange and more coordination. So that is the challenge for intermodal carrier. I also want to say a little bit about transportation policies. So relating to transportation, of course, is highly dependent on what the government has built for us, the infrastructure, the policy components for transportation sectors. And whatever policy is imposed or removed is going to have a very large impact on the transportation sector, which transportation mode is used more or less. So, for example, in the rail industry, in the beginning of it, the government had a subsidy for rail industry, which really made a lot of rail companies prosper. And that led to monopoly behavior and collusion behavior and drove up the rail shipment prices. And then the government again came in to regulate the industry and basically prohibited collusion and prohibited monopoly behavior, which in mid 20th century became a problem for the rail industry because of the increased use of other transportation modes. So then the government had to deregulate rail sector, and then the rail sector was able to recover and have more profitable operations, and also logistic and shipments overall are increasingly use rail as a transportation mode. So from the perspective of the public sector or the government, one decision about transportation policy is how much to charge for the use of these public infrastructure. Right, so one thing we often see are like toll roads, and also payment lanes, paid lanes when there is heavy traffic, right? So the reason for that is to capture the marginal impact of each person using the transportation infrastructure on society. Okay, so for example, if you imagine, when the cost of traveling from one place to another is going to be higher if there is a very heavy traffic as opposed to no traffic, right? And as more and more people join this transportation infrastructure, the traffic is going to be heavier and heavier. So, but without charging a pricing scheme, the cost is bared, as say I join this traffic and I'm making it heavier, but the cost I impose on this traffic is equally shared by everybody. So basically the cost seen by myself is only a small fraction of it. And the motivation of these pricing structures is to capture more of the impact on others, on the whole system, by introducing a monetary fee, right, to actually more accurately capture the marginal cost of a person joining the transportation service. And that would, for example, when traffic is heavy, it would discourage people from joining a particular road more and more. So in terms of transportation network, when we're talking about supply chain, how do we move products from suppliers to customers? So when we design a transportation network, what are the options? So one option is, do we do direct transportation, or do we add any intermediate nodes? And the other one is, for this intermediate nodes, what property does it have? Is it a storage facility, or is it a production facility, assembly facility, or is it just a cross-docking facility? So cross-docking means that the product immediately flows through without being warehoused in a facility. And finally, when we are delivering products to customers, should we do a single destination on each delivery run, or should we include multiple destinations? So combinations of the answer to these three questions will lead to different designs of our transportation network. So the first design is direct shipment to a single destination. So this is the most straightforward, right? Say we have a number of suppliers and a number of buyers, and the shipment from the supplier to a buyer is by directly connecting those two. Right? I just send a dedicated truck to transport whatever I want to ship to this buyer on this truck. And so the major, let's think, what are the advantages of this direct shipment?
Less coordination.
Less coordination.
Less touches.
Less.
Less touches. Each touch, the price increase to move the product.
Right. So less, basically less coordination, right? So basically less coordination because basically this transportation trip is completely unaffected by other arrows, right? So I can single out this thing and I plan it by itself. And this is much simpler than if every time I plan, I have to plan all the arrows. And the other benefit of this is what? It's faster, right? We don't have to stop in the middle. So good things are fast and there's little coordination needed. What about the downside?
Costly.
Costly how?
Single truck is, I mean, if you are supplying for each and every buyer,
Mm-hmm.
you should actually allocate a separate truck to it.
Mm-hmm.
Truck has to come back empty and then
There has to be
another
no
load and
back.
go to a different location. So
Right, so then we have low utilization of the truck.
Then truckload.
Uh, So in fact, what will likely happen is that in order to utilize the truck capacity high, then the order decisions would be very high, right? Each time we order, it's going to be a large lot size. So then the result of that is high
Risk. Risk.
high risk, but also high what?
what
Inventory.
High inventory. So this transportation node is justified when basically the demand at the buyer locations are large enough that the large lot sizes are actually justified. So a modification of this direct shipment to single destination is direct shipment with milk runs. So I'm still transporting suppliers to buyers directly, but each shipment contains shipments to multiple buyers, for example, is one scenario. The second scenario is milk run on the supplier side. Right, so when I pick up suppliers' shipments, I pick up multiple from multiple supplier locations. So comparing to direct shipment with a single location, what is the benefit of this one?
Where
A single truck can
Still
supply
variation of
different
More
items
than
at the same time.
the same truck
But
can
the same
be
truck
utilized for
can be-
3 different
Yeah,
types of
what's the
locations.
benefit of that?
more
High
utilization.
utilization of the
High utilization. Yes. High utilization and therefore lower transportation cost per unit. And another benefit of this is what? Comparing to here.
Moderate to low inventory.
Lower inventory. Right, because now if we deliver to multiple buyers, each buyer doesn't have to order a very large order size. The downside of this one compared to single location,
More coordination.
more coordination. So, milk runs make sense when the quantity for each buyer location is too small to fill the truck, but multiple locations, these buyer locations are close enough to justify that they can be combined on the same truck. Right? If they're very far away, then it doesn't make sense to combine them on a milk run. I might as well ship them directly from the supplier.
What is the arrow in the dotted?
The return
Oh,
return of the truck with a possibly empty load. Yeah. Okay, so another different type of transportation structure is an intermediate distribution center with storage. So here, we have the suppliers will send their shipments to the central DC, and this DC will store these shipments until they're actually requested by the buyers, and then the DC will ship to each buyer's location separately. So, what is the advantage of this one?
Ease of coordination.
less inventory.
Ease of coordination.
Responsive. Very responsive.
So that is debatable, right? There's part that's less coordination because the direct shipment to buyer locations comparing to milk run. But there's coordination needed to store at DC, right? So what is another advantage?
Fast deliveries.
Faster?
Yeah. If you see from DC to
Okay.
buyer location, but the entire process will be a bit slow as compared to direct.
Okay. So smaller lead time for the buyer. Yep. What else?
Cost effective.
Low transportation.
Effective how?
If you have a DC in a common location near the buyers,
Uh-huh.
Like a last mile.
like yeah,
Okay.
The diesel rate and cost.
So, but then it still is longer than directly shipping from the supplier to the buyer, right? So then where is another benefit coming from? Why do I want to consolidate at DC?
At the buyer's location, actually the inventory can be less.
Okay, why can the buyer's inventory be less?
Because
They can order in
lesser
lots.
quantities since there is a distribution center nearby.
Okay, because of the lead time, it can lower inventory. Yeah. Anything else?
More responsive system.
Yes. So because that's same as faster lead time, right?
Yeah.
Okay. Another benefit is because of consolidation. Right. Imagine, I'm shipping product 1 from supplier 1, product 2 from supplier 2, both of which are required by buyer 1. Then at DC, I can combine these two shipments to ship to buyer 2, buyer 1. So consolidating inbound transportation. The drawback?
Risk.
More inventory at DC.
More inventory at DC, yes. Okay, so this structure makes sense if the shipment from each supplier is large enough to justify for their own shipment, and either the buyer's demand is high enough to justify for their own shipments, or their locations are far away, or their shipments cannot be coordinated. A slight modification of this infrastructure is instead of a DC, I have just a cross-docking facility. So it doesn't hold inventory. Okay, so comparing to, cross-docking facility comparing to DC, the main features are the same. The only difference is, one, it's eliminate the need to store inventory, right? So that's a benefit. The drawback
Lead time will increase.
is
Lot of coordination.
lots of coordination. So because now the arrivals and departures at cross-docking locations have to be coordinated, for them to be about the same time. And then we can also do shipping via an intermediate location, whether it's a DC or a cross-docking location with milk runs. Right. So why we use milk runs and the benefit are similar to before why we use milk runs. And similarly, this milk run can be from the supplier side as well. Right. Can be like this. Now, so when we decide which transportation network structure to use for a particular product or a particular group of customers, we need to evaluate the pros and cons. But in addition to each of the network structure we looked at, we also want to point out this tailored network option. So tailored network option is basically we're going to combine all of a subset of all the above options to satisfy one or many products in the supply chain or two different sectors of customers. Right? So I can, for example, ship direct my high demand products and ship the low demand products with a cross-docking or intermediate DC location. And so this complexity of tailoring a transportation network is very high because there's many combinations of what's possible. And also we need to trade off different costs involved. Right? We not only want to look at the cost of transportation, but we also want to look at the cost related to inventory. So this brings us to the main trade-off for transportation design. So the main trade-off is transportation versus inventory. Now, generally the higher transportation cost, the less inventory cost, because higher transportation cost means faster transportation, and there is less need for carrying inventory. And then there's also a trade-off between cost of transportation and responsiveness. Of course, higher cost transportation is faster and more responsive. And to determine the appropriate transportation and inventory trade-off, we choose the appropriate mode of transportation that achieve the appropriate level of responsiveness in our supply chain, and also achieve the appropriate level of inventory aggregation in our supply chain. So the shipper must determine what is the balance point between transportation and inventory cost. So modes with high transportation costs can be justified if they can significantly reduce inventory cost. So this is what Apple did, right? They outsource production to China, but they don't want to sacrifice responsiveness. So in vast majority, they use a lot of transportation for their products is air. And so this is obviously very expensive, but it's also justified by the added value of responsiveness and because their products are high value per item. So this, the responsiveness carried implied higher revenue, higher capture of customer markets is well over to justify the high transportation cost. So this table just compares for us different transportation nodes on the performance related to inventory and transportation. So as we move from package carrier mode is the most expensive mode, but it's also the fastest, most reliable mode. So then this would lead to the lowest level of inventory, whether it's cycle inventory or safety inventory. It will lead to highest level of transportation cost, but also shortens transportation time. And we move down this list, inventory will increase, transportation cost will decrease. And responsive time will also increase. So, when we design transportation network, we're trading off the transportation cost and inventory cost. So the decision of designing transportation network is actually very closely coupled with inventory aggregation decisions. So, inventory aggregation happens when we consolidate locations, right? And rather than distributed locations close to customers, we may have a centralized location farther away from customers. And when we aggregate inventory, the benefit of aggregation we discussed before is we can cancel out some inventory demand uncertainties and therefore reduce the level of safety inventory required. But it also leads to longer transportation distances, and which will, of course, increase transportation cost and increase the response time. So then when we use inventory aggregation, we need to consider its effect on transportation as well, right? So we only aggregate inventory when the total cost from inventory the inventory and facility cost savings due to inventory aggregation is actually a majority of our total cost. So it outweighs whatever effect it has on transportation cost. And for product with a large value to weight ratio, it also makes sense to do inventory aggregation, right? Because if the product is very expensive, inventory cost is also very high, and therefore, for example, for diamond, we also often have a very centralized location where we can use some of the inventory aggregate benefits, but then we use very fast transportation mode to still maintain a responsive supply chain. When demand uncertainty is high, we want to use inventory aggregation. So this is summarized in this table. When do we want to aggregate inventory? When transportation cost is low, demand uncertainty is high, holding cost is high, and customer order size is large. And disaggregate otherwise. And when we're trading off between the cost of transportation and the responsiveness of the supply chain, the one way to look at this trade-off is how much we need to aggregate temporarily. So the more we aggregate, that means we're combining a longer period times demand into one transportation shipment. So that means larger order size, longer transportation lead time, and less responsiveness, but lower transportation costs because we can utilize economy of scale. Finally, tailored transportation. When we're tailoring our transportation network design, we need to look at what are the effects on different customer segments and different products. So the determining factors that affects what is the most appropriate transportation network include what is the customer density and how far is the facility to customers. Customer size, this is generally referring to customer being businesses. So how large are their orders? And also the demand, overall demand for the product and the value of the product. So, and the costs, we need to consider transportation costs and inventory costs. And the transportation costs, especially when we have the milk runs, will include not only the transportation costs on determined by the total distance traveled, but also on how many deliveries we need to make. Right, the more number of deliveries made, the higher the cost. So the best transportation options based on customer density and distance. So basically, as density increases and as distances decrease, it will makes more sense for us to, one, have more ownership in our transportation fleet and use more milk runs. Okay, so basically if we're moving in this direction, that means more ownership and more milk runs. So, as density increases, it makes more economic sense to do milk runs. And as the distances decrease, it also makes more sense to do milk runs rather than use dedicated trucks. Yes?
What do you mean by density of the customer?
Density of the customer meaning how close are customers located between one another. Right, so for a retail store, we're looking at households. Then Ann Arbor compared to New York City. New York City is higher density, and it makes more economic sense to do these delivery services because everyone is tightly packed in the same location. Right, so milk runs is more economical. In terms of the effect of demand variability, or sorry, demand level and product value. So as the demand becomes higher and as value becomes higher, so again, in this direction, what it implies that we need more responsiveness. In terms of inventory aggregation, is it more or less inventory aggregation?
That's aggregation.
That's more?
Yes.
Less aggregation. Okay, so any questions? If not, let's take a break. Okay, let's continue. So for the remainder of the course, we're going to look at several functional modules in a supply chain. The next topic, we're going to look at sourcing as a function. So one, we're going to understand what are the influencing factors to making sourcing decisions, and what are the performance measures that we care about to evaluate suppliers. And then also describe what are the incentives to drive the desired behavior from third-party suppliers in a supply chain. And finally, discussing how do we share risks and benefits in a supply chain. So within sourcing, to clarify a few terms, we have, in sourcing we have purchasing. So purchasing is the act or the process of acquiring materials, components, products, services, or any other resources from suppliers in order to fulfill our operations. And so sourcing is more of an umbrella term that includes purchasing and any other related functions. So it includes any set of business processes required to purchase goods or services. And any supply chain function, the most significant decision in terms of sourcing is about whether to purchase from an outside source or do it in-house. So then that is the outsourcing decision. So basically outsourcing is the decision to source a supply chain function, whether it's material, products, service, or any other resources to be performed at an unaffiliated third party. So this is as opposed to insourcing. So we could still get material, get services, and products from internal resources, right? And if that is the case, then we call it insourcing, and it's what we're going to focus on is the decision to whether to buy from an outside supplier or not. So we're going to focus on the outsourcing function in particular. So in order to decide whether to outsource or not, we need to answer a few questions. One is, what is the added benefit, right? If we purchase from a third party, then does it actually increase my supply chain surplus? And if so, how much does it increase? And then whenever we do outsourcing, there is related risks. So we need to evaluate what are the risks involved, how much they are, can they be justified by the added surplus, and finally, are there any strategic reasons forcing us to outsource? So how can third parties increase supply chain surplus? So generally, we outsource to a third party, if not for strategic reasons, is because this third party is able to aggregate supply chain assets or flows on a higher level than the firm itself. So, for example, they could be aggregating capacity. For example, this is to say the third party is able to aggregate demand across multiple firms and gain production economy of scale that no single firm can on its own. So, for example, we could have a automotive assembly supplier that is able to outsource its assembly capacity to different automakers, right? Usually this would relate to small automakers or automakers, large automakers, less low demand models, right? So, this company, Magna Steyr, is the assembly supplier for BMW and Mercedes low demand models. Another way to aggregate for third-party supplier to be better at aggregation is through aggregating inventory. So again, where this third-party supplier is likely to be able to aggregate inventory from a large number of customers. And so, for example, W.W. Grainer is the maintenance tool supplier, right? And they primarily aggregate inventory from multiple customers, and because of the inventory aggregation effect, they can cancel out some of the demand uncertainties between different customers, and these customers by themselves cannot achieve this inventory aggregation effect. So by sourcing inventory to these outside parties, the customers is able to decrease their inventory cost. One can also aggregate transportation. So this is what's done by UPS, FedEx, right? So they, the shipments quantities to each individual customers are very small, and if they were to use their transportation by themselves, there's very little economy of scale. Now, by aggregating transportation needs, UPS and FedEx is able to exploit some of that economy of scale, and so provide value in that way. Similarly, we also see transportation aggregation through inventory storage intermediaries. So basically like the infrastructure you saw with the intermediate DC. The only difference is the DC is a third party, it's not owned by the company. So there, you receive aggregation benefits based on storage. Warehousing aggregation, so if the supplier has an existing warehouse space and each customer, maybe they're small, right? It's non-economical for them to rent a large warehouse to store a small number of products. But if the supplier works with multiple small customers, then they're able to aggregate these inventory storage needs into their warehouse. And then you can also aggregate procurement process. So basically imagine if you have a third party that takes care of the procurement process to different suppliers for you. So this and is basically a part of relationship aggregation, where this third party can leverage their existing relationship with multiple either suppliers or buyers. And so then, the point of relationship aggregation is, if we have a set of suppliers and a set of buyers, if each one of them have to work with each other to establish relationships, there has to be, a large number of relationships established. But if we have an intermediate party, this third party that does relationship or procurement, then what we need to do is only 6 relationship pairs. So then that reduces the cost of information sharing, the cost of coordination. So then the procurement process or building relationship process is less costly for all parties involved. We also have information aggregation. So for there, you can think of it as more of an online platform that aggregates, it's sort of like a search engine sometimes. You can aggregate the information from multiple companies, whether it's potential suppliers or potential buyers. For example, some third-party shipping websites will look for, for shipping suppliers or carriers for different shippers. Receivable aggregation is also sort of like relationship aggregation. So basically, receivable is the part that companies collect revenue from their customers, right? And again, if we have a set number of customers and we can leverage a third-party service to collect from these customers, and if we have multiple companies wanting to collect with each of these customers, then by working with a third party, that saves a lot of relationships and saves a lot of information exchange. And another reason for sourcing to third party is strictly because they have either lower costs or higher quality. So basically, if this is a sustainable way a sustainable reason to outsource to a third party, that would generally imply that this supplier has more advanced technology. They're farther away on the learning curve. So then it, sourcing from this third-party supplier in the long run would make sense. But if the supplier is lower cost only because they have more access to lower cost labor, then it's questionable whether we should really outsource it to unaffiliated member or unaffiliated supplier, or just build a production or sourcing facility ourselves. So then if a third party can provide surplus, then over time, how does this surplus change? And what are the factors that would increase the surplus? What are the factors that would decrease the surplus? So this amount of surplus is largely dependent on the scale of the focal company. Right? If the company is very large scale already, then it's very unlikely they would be able to leverage any additional aggregation from a third-party supplier. So this is why, Walmart is probably, it's very difficult for them to find a more cost-efficient supplier than building something themselves. Another element is uncertainty. So if we have very highly variable requirement over time, then the third party is potentially able to aggregate these uncertainties with other customers. So then the aggregation effect will reduce the total variability and then therefore reduce the uncertainty faced by each customer. So higher uncertainty would make third party more valuable. And thirdly, specificity of asset. Basically, this means if there is an asset or a process that is specifically to a firm, right? So nobody else used this asset, nobody else used this process, then it doesn't make sense to outsource, because since no one else used this asset, the third party has no power to aggregate with anyone else. And then it also, of course, depends on whether this third party has any cost advantages, either because their unit cost is lower or it's easier for them to acquire capital. So this is, for example, when startup companies ask for venture capital funding. This is because they have more available capital. So this is just a summary of what we just discussed, and you can go through it yourself. So other than the upside, there's downside of using a third party. So what are the downsides? The biggest problem related to using a third party is that the process is broken. So basically, somewhere through outsourcing, you're losing control of the process. And that is a major concern. Another risk or another element that is often underestimated by companies that when they're making outsourcing decisions is the cost of coordination. Right? So, the cost of using a third-party supplier versus insourcing this function, obviously it's easier to coordinate with ourselves than with a third-party supplier. And then, in cases where outsourcing the processes related to procurement or the processes related to sales, right? Adding intermediary third-party suppliers could reduce the contact with our suppliers or to our buyers. And that could be a very undesirable feature because supplier and customer contact are often important. And sourcing to a third party could lead to a reduction of our own capability. And this is important if this capability is core to our business. In addition, it could also lead to a growth in this third-party supplier's power. So this is whenever we have a supply chain relationship, there's bargaining power involved. Right? So because we need to, between supply chain members, we need to set contract terms, we need to negotiate how to divide the supply chain surplus. So each company do not want the others in the supply chain to get more power, so then through the bargain, we would obtain more surplus. Data sensitivity is another concern. Right? So the leakage of intellectual property, the leakage of sensitive customer data are major concerns in today's world. And so this is especially a concern if we're working with a third-party company that also works with our competitors. So leakage to competitors is also a very serious concern. Another concern is whether the contract terms are actually effective. So when the contract terms are ineffective, it could generate wrong incentives for these third parties. So for example, if we set a contract term that requires suppliers to maintain a certain number of days of inventory, then that eliminates the incentive for them to reduce inventory. Or similarly for customers. Right? So that may be the good thing, right thing to do, and may not. But in working with third party, there is always the risk of misaligned interest. So contract terms are crucial. And so last case study, we talked about the importance of supply chain visibility. Adding more intermediate steps that are not a part of us will reduce this visibility, and that could lead to serious problems. Especially when the supply chain is long. And finally, in today's world, when customers care about a lot of, corporate responsibility issues, environmental issues, social issues, then reputational effect is also a main effect. So outsourcing to third party reduces transparency, reduces visibility, and reduces control. Right? And then this could often lead to very negative reputational effects. So for example, Apple outsourced their production to Foxconn, who had a lot of labor abuse issues, and Apple, because of that, had a lot of negative reputational effects. So finally, there are still some strategic factors in determining whether to outsource or not. One is whether outsourcing is aligned with our business strategy or not. Right? So certain companies have business strategies that align with outsourcing or misalign with outsourcing. For example, the Harley Davidson has this made in America image, right? And then that determines their sourcing strategy has to be suppliers within the United States. And outsourcing can also be a tool for improving the focus of the company. Right? So in order to keep focus, we have to identify what are core processes and functions to the company, what actually provides competitive advantage. So then we can outsource everything that's not. And that will keep us focused on our competitive advantage. So in making outsourcing decisions, we need to consider the total cost of ownership. So total cost of ownership is not just the prices quoted by your supplier. There's also costs related to other functions of the supply chain. So there are 3 buckets of total cost of ownership: parts related to acquisition, parts related to ownership, and parts related to post-ownership. So in acquisition, so this is the part where this say is the timeline of the company. Then this is the cost that's related to anything from the purchase of the material until the materials are ready to be used. So this is from purchase to material not only arrived but also ready to be used. And this is our acquisition cost. So acquisition cost includes the price for the product, for the material, and also includes what are the terms of the suppliers, which may include any quantity discount or include any requirements on the lot size or delivery frequency or payment terms. Taxes and duties, this is particularly important if we're sourcing from an overseas location. So any export or import tariffs, any compliance issues because of the difference in regulations between the different countries. And then there's also the cost of delivery, transportation cost, and incoming quantity cost. So this is the part before making sure the material is ready to use. So we have to inspect the shipments, making sure there is no defective products or no need to rework. If there's any defective, then we may need to send it back to supplier. And on top of that, we also need to account for the costs associated with the overhead of managing the relationship and planning the purchases. So all the first 5 components are easy to quantify, but the costs related to managing and planning relationships and purchases is difficult to estimate. So the second part of total cost of ownership is the actual ownership cost. So this is between the point that we just, so material ready to use to the final product sold to customer. So this is the portion of that's ownership cost. So here we will incur inventory, and this inventory relates to any products that occur from this point to this point. So it could be raw material, could be semi-finished products, could be finished product. And then we need warehouse to store this inventory. So there's warehousing costs. And if this is actually a manufacturing process, then there is also manufacturing cost. And production quality cost, so this is particularly the part of quality penalty due to the sourced product. So as you can imagine, this is hard to trace down. Another part is the cycle time cost. So because of the properties, the characteristics of the source part, is it adding or subtracting from our cycle time? And then the post-ownership costs. So everything happens after the product is sold. Now, we talked about reputation cost. So because of the sourcing, the sourced product, the sourced material, is it resulting in any reputation impact of quality problems? And if there's any warranty offered or product liability issues because specifically related to the source part, and any environmental costs, any supplier capability issues in case that we need to, for example, request a replacement product for the customer. So all of these post-ownership costs are pretty hard to estimate. So looking at this, total cost of ownership, and let's recall Zara's decision to source some of their high trend products to the European location instead of Asian location, right? How does that affect various aspects of the total cost of ownership? So let's first look at acquisition cost. Right. Acquisition cost, does that decision increase or decrease acquisition cost?
Increases.
Increases, right?
Yeah.
Because the European location is higher price. in terms of ownership cost, how does it affect ownership cost? So inventory cost, how does it affect?
It would be increased.
Inventory cost decreases.
Decrease, right?
Storing the items of Zara, any products of Zara would actually increase the holding cost, right? Everything under raw material, finished goods, everything.
No, because the fact that they are able to, they put it in Europe is one to reduce the lead time, right? And the effect of reducing lead time is reducing the inventory, cycle inventory needed, and also safety inventory due to forecast accuracy, right? So therefore, there's much less need for inventory. And similarly, warehousing cost might decrease, but depend on the cost of rent in the local area. So not sure in this part. Manufacturing costs,
No manufacturing.
probably higher, right? Comparing to the Asian low-cost countries. Production quality costs.
So the
Decreases.
Same demand.
Decreases because we assume it's easier to monitor the product quality, right? And then also, if there's any quality defects, it's easier to rectify. Cycle time cost. Decreases. This is a major save, right? Because the cycle time reduced actually allowed us to reduce the shortage cost significantly. So post-ownership costs we're not going to evaluate because it's really hard to say. But basically, through that decision, Zara is able to significantly reduce their total cost of ownership because of the reduced inventory and cycle time costs, even though acquisition cost is increased. Okay, so when we design a sourcing portfolio, we need to decide who and where to source from. So one is the outsourcing decision, right? So do we produce in-house or do we source to a third party? And if we do source to a third party, what are the characteristics of the third party we're looking for? Are we looking for a low-cost supplier, or we're looking for a responsive supplier? And additionally, where is the supplier located? Is it onshore, meaning that the supplier's location is the same place as the market where the product is sold? Nearshoring basically refers to producing a product at a lower cost but near the market. Offshoring, so producing at a low cost location that probably is far away from the market. So tailored sourcing, we tailor the supplier's portfolio based on the products and market characteristics. And the firm is going to trade off the two options, right? One is focused on cost, but we have less responsiveness, unable to handle uncertainty very well. And the other is we have a lot of uncertainty and a lot of responsiveness, but it comes at a higher cost. And so to do that, one way to achieve the tailored sourcing solution is through volume-based tailored sourcing. So in volume-based tailored sourcing, we're basically sourcing the predictable parts of the product demand to an efficient facility or efficient supplier and source the uncertain portion to a responsive supplier. So an example of this volume-based tailored sourcing is Benetton, who asked their retailers to, so they have flexible capacity and more cost-efficient capacity. And then they asked their buyers to say, tell them in far advance what likely their orders is going to be. Right? And then they produce that portion on the cost-efficient facilities. And then they also allow their buyers to adjust this order quantity close to when demand actually occurs. So then, whenever there is any changes or modification to the order quantity, they're able to utilize their efficient capacity to produce these orders. Another example way is product-based tailoring, tailored sourcing. So this is to say the low volume products with high uncertainty are going to be sourced from a responsive source, whereas high volume but low uncertainty products are going to be sourced from a cost-efficient source. So basically, product-based tailored sourcing is what Zara used in our previous example. All right, so now let's look at some decisions. Let's say we're for different characteristics, we're choosing whether to use a responsive source or a low-cost source. Okay? So let's first look at product life cycle. Now, basically where the product is in its life cycle. If it's an early cycle product, where should we source from?
Low cost, early stages. I mean, in the manufacturing.
Responsive.
Responsive.
Thinking.
Why is that?
Because there are a lot of uncertainty and a lot of iterations need to be done. So.
Yep.
the
So
demand
in
certainty is not-
early stage products, there is a lot of uncertainty, product volume is low, demand is low. So then we need responsiveness more than cost efficiency. And then late stage products, volume is high, demand is stable, then we can take advantage of the cost economy of scale of low cost sources. So that basically explains what we would do facing different levels of demand volatility. Right? If we have a high volatility, then we need responsive and low for low cost. Demand volume,
low high.
yep. Product value,
Responsive low high.
high value is responsive source, low value for low cost source. Rate of product obsolescence.
High.
If there's a high level of obsolescence, then we want a responsive source. otherwise low cost. Desired quality. If quality desired is high, if the engineering or design support required is high,
Responsive.
responsive. Okay, now let's look at the decision of where to source. Okay, whether to onshore, nearshore, offshore. So as you can imagine, the nearshore decision is somewhere in the middle. So we're gonna focus on the decision of onshore versus offshore. All right, so if the product rate of innovation or is high, or product variety is high, should we onshore or offshore?
Onshore.
Onshore. Demand volatility is high,
Same. Onshore.
onshore. Labor content. So how much labor is involved? Let's imagine, so we need to define onshore first. Let's say onshore is United States.
Offshore.
Labor content is low,
No.
then we onshore, right? And then if it's high, then we offshore to low-cost suppliers. Volume to or weight to value ratio, which basically means if the product is bulky or yeah, so volume weight to value ratio is high, meaning it's bulky and possibly less valuable. Onshore. Because the transportation of bulky items are very costly, right? Impact of supply chain disruption. So basically, if there is a large impact for if there is something wrong, something went wrong in the supply chain. Onshore? Why is that?
Easier to manage it, any disruptions.
Easier to manage, higher visibility, right? Yep. Inventory cost. If it's high, wait, offshore? Onshore. Because if we offshore, that generally means large order size, right? If engineering support is needed, onshore. Yep. Good. So another reason, another issue we need to consider is when sourcing is the incentive issues, right? If we're outsourcing, then there is a potential of misaligned incentives. And as we have seen many times before, misaligned incentives in supply chains could lead to reduced supply chain performance. So alignment is important. And alignment is important and difficult when the third-party actions are not easily observable, right? So we cannot easily say the supplier has put in more efforts or not. And we also would need a smarter alignment incentive when the third party has private information. Right, so for example, if we're selling to a retailer who has direct information about the demand, so this is information, without information sharing, this information is not available to us, then designing a smart contract term with a proper incentive is important to induce the correct behavior of the retailer. And these incentives can be tools for the contract designer to communicate what are the properties of desired performance, right? Do we want you to order more or less? Do we want faster or slower responses, and so on. One commonly observed incentive structure is these threshold incentives. So, for example, as you saw in quantity discount, we have these thresholds for when quantity discounts are applied. And similarly for sales, we also have these thresholds of sales targets. Say, for example, we could have a car maker working with dealers, and they would say, okay, if you sell more than 100 units, then I'll pay you more, per unit sold. So this theoretically would be incentive for the dealers to sell more, right? But it actually can lead to distorted information because one, the target may not be set appropriately, right? If we set the target too high, say the demand is usually around 50 units, then the incentive may not work or even be a discouragement because more effort is not going to lead to more reward. And another issue is it can actually lead to more of the bullwhip effect we talked about because, say there's potentially an incentive to shift more demand into a particular time period to capture more of this payment. So that would artificially create these demand spikes. And so to the automaker, this demand information is getting distorted. So this is not a desirable structure, so we want to generally avoid these threshold incentives. So then how do we share risk and reward in supply chain? So generally we want to, as the goal of the supply chain, we want to align the incentives of everybody so that the size of the pie is larger. But in reality, it's oftentimes that firms don't care about the size of the total pie, but cares about what are the portions that each companies get. So this will lead to these bullying effect in supply chains where the party with stronger bargaining power will push all the risk to weaker parties and extract all the benefits of all the profit of the supply chain to the stronger parties. So to see this effect of a misaligning incentives, let's go back to our model for optimal service level. Right. So this is just recap of what we had learned before. So this is how we calculate the optimal order quantity for a given service level, right? And we know the sales price, we know the purchase cost, potential salvage value, and the demand distribution, assuming demand is normal. CSL is the optimal cycle service level, and O star is the optimal order quantity. And we're looking at a simple scenario where the company is making a one-time ordering decision facing uncertain demand. Right, so there's a possibility of under-ordering and possibility of over-ordering. And CU is the cost of under-ordering, which is equal to P minus C. And CS is the cost of over-ordering, which is equal to the cost C minus S. And we also talked about these formulas, how to calculate the expected profit for the company, the expected number of overstock, expected understock for the company. All right, so we have learned all of this before, and this is the formula for a single company. Now we want to look at what if there are multiple parties in the supply chain, right? So one is we look at, say, a supply chain with a manufacturer and a retailer, right? So the manufacturing cost is $1, and we say denote this as V. So this is V, and the mean demand, the wholesale price is $5. Let's say it's W. So this is W, and then the retail price, say it's P, or sorry, not W, C. This is C, and then P here. This is P. All right, so salvage cost here we ignore, so assume it's 0. Now, without an incentive mechanism, without trying to coordinate the supply chain, the retailer will just look at its own problem, right? So the retailer is segmented here. It will calculate its overage cost and underage cost. The overage cost is P minus C minus S, so $5. Underage cost is P minus C, also $5. Okay, so then we can calculate the target service level, which is CU divided by CO plus CU, so which is equal to 0.5, quite low, right? And using the order quantity formula, we can calculate the retailer's decision of its own order quantity is 1,000. And then we can use these formulas right here to calculate the expected profit for the retailer. So this is using the formula from the previous slide. And the manufacturer's profit is equal to what? How do we calculate this? How many units did manufacturers sell?
1,000.
1,000, right? Yeah, so this is basically the retailer's order quantity times the manufacturer's profit margin, which is C minus V. Okay, so 4 times 1,000. Now the total supply chain profit is 7,803. Okay, so now let's consider a case where the supply chain is trying to do its best by vertically integrate the whole supply chain. So this is now the case where, again, we have manufacturer, we have the retailer, but the two act as a one entity. So now we have, as the single entity, the supply chain, now its overage cost is, what's the overage cost? It's V minus S, correct? V is the purchase cost, and S is 0, so equal to 1. The underage cost is P minus,
S.
Minus.
Oh, the manufacturing cost.
V. Yep. So equal to 9 in this case. All right, following me? Okay, so then for the supply chain, the target service level should be 0.9 instead of 0.5. Then if we use this target service level to solve for the optimal order quantity, it's equal to 1,384. Then we can calculate the total supply chain profit, again using this formula, but replacing C by V. Yep. So it turns out the total supply chain profit, and this is the best we can do, is $8,474, which is compared to before, if retailer makes its own decision, it's significantly higher. So then the question is, why, when the retailer makes its own decision, one observation is we can see it orders significantly less than the supply chain optimal decision, right? So then the question is, why does it order so much less? You might find some indication from comparing these costs, right? So for the retailer, this cost is much higher, which means what?
If he orders more, he's going to put a lot of money, and there will be loss of due to overage.
Right. So if there is inventory overage, then this retailer is going to incur a lot of cost. So basically, in the natural case where supply chain is not integrated, all the inventory risk is borne by who? The retailer. So which would discourage the retailer from ordering more, right? Now, therefore, as the manufacturer, obviously we want the retailer to order more so we can make more money. And from the supply chain perspective, it's also the better thing to do. So then the question is, how do we incentivize the retailer to order more? And the answer lies in reducing inventory risk for the retailer. Yeah? So somehow we're going to create a mechanism that the retailer's inventory risk is reduced. And that can be done by a number of mechanisms. We're just going to name a few. Right. One is buyback or return contract. And then we also have revenue sharing contract, quantity flexibility, and we also have a number of other contracts that can do this. So let's just quickly look at how one of these contracts, the buyback contracts, is going to facilitate the incentive. So what is the buyback contract? The buyback contract, really what it does is to say to the retailer, you know, if you don't sell the inventory at the end of the selling season, then I'll buy back from you at a not as a high price as the retail price, but it's better than your salvage cost. Okay, so in that case, in that sense, the retailer's inventory risk is reduced, right? And so in a contract, what we're going to specify is on top of the wholesale price, we're going to specify what is the buyback price. And now the inventory is salvaged by the manufacturer after they buy it back from the retailer at a certain cost, which we will also ignore in our example. And the other assumptions are similar as before. So price is also, retail price is P, and manufacturing cost is B. Now, the manufacturer's profit in this case, this is our original manufacturing cost. Now, the manufacturer also incurs a cost by buying back this inventory for higher cost than salvage, right? So each unit they buy back from the retailer, they're going to incur a cost of B minus SM. And then this multiplied by whatever is left over at the retailer is going to be the additional costs incurred by the manufacturer. So then simply for the retailer now, since the buyback price basically becomes the new salvage cost for the retailer, right? Then the overage cost becomes 5 minus 3 instead of 5 minus 0. So overage cost is obviously lower than before, and underage cost is the same. So the target service level becomes 0.71, an increase from 0.5. And as a result, the order quantity also increases. And we can calculate the expected profit by the retailer is higher, because now the manufacturer shares the inventory risk. Now the expected overstock can also be calculated, and then we can compute the manufacturer's profit. And somehow manufacturer's profit is also increased, right? Because what? Because the supply chain's total pie is larger now. And we can see the supply chain profit is now higher than before. So this is the value of aligning incentives. And in designing the contract, what we're going to do is to look at combinations of the wholesale price and the buyback price. Each combination will lead to different total supply chain profit and different distributions of this profit among the two parties. Okay, so as the supply chain, we would like to pick the combination that maximizes supply chain profit. But in contract design, this is out of the scope in this class, but I just want to mention that you also want to make sure that both companies are better off than they originally are, so that they actually want to participate in this contract. Okay. In fact, using just the buyback contract itself, we can always achieve the supply chain optimal profit. You can always find the pair to do that. And some additional comment for the buyback contract. One is in some instances, the manufacturer will use holding cost subsidies instead of buyback price for reducing the retailer's inventory cost. So basically, they're saying if they have excessive inventory, then we're going to share a certain portion of that inventory cost. And then another mechanism is price support. So this is often happens when there is a product with high obsolescence rate. So high-tech products, for example. Then, because of the high obsolescence, that deters the retailer from ordering more, right? And now with the price support, the manufacturer is saying, okay, don't worry too much about obsolescence. If it goes obsolete, then I'm going to pay you more money and let you recover your profit.
Is it same as payback, increasing the payback price?
Not quite, because this is to say the retailer can actually sell it with a discount price, but the reduced profit from the discount is going to be compensated by the manufacturer. Yep. And then, some additional two other mechanisms are revenue sharing and quantity flexibility. They both serve as a similar mechanism to share inventory costs and inventory risk. So basically, revenue sharing is a mechanism where the manufacturer will charge a very low wholesale price, oftentimes the actual manufacturing cost to the supplier, to the retailer. But as a return, it asks the retailer to share a part of their revenue, their retail revenue, with the manufacturer. So, and then the quantity flexibility contract says, basically what Benetton does. It asks for the buyer first to identify a order quantity, and when it's closer to the selling season, it allows the buyer to adjust this order quantity to some extent. Which is actually serving as a mechanism to better match supply with demand, right? And then it also allows for more accurate information transmitted through the supply chain. Similar as sharing risk, you can also share rewards. So, for example, the buyer may want some performance improvements. For example, reducing the lead time for selling a seasonal item, so that they can forecast more accurately. Then the supplier, of course, doesn't have an incentive to do that, because if I reduce, lead time and information is more accurate, then the retailer's safety inventory would reduce, right? And that would mean the retailer will buy less from the supplier. So a way to mitigate that is through these shared savings contracts, to say, okay, so the savings incurred at the retailer side, with their overage and shortage costs, is going to be shared with the supplier for allowing them to shorten the lead time. So on the other side of the story is aligning incentive to share the performance rewards in addition to sharing risk. And of course, you can use a combination of these two to create more strong incentives. All right. Questions? All right, that's it for today.